Welcome to this LED matrix build tutorial. In this video, we'll walk through the complete assembly process from start to finish. By the end, you'll have a fully functional LED matrix controller powered by an Arduino Nano and ready for your own custom projects. Let's start by assembling the main structure. As you build the box, make sure the side with the buttonholes is facing up and away from the table. We're building the structure upside down, so take your time to keep everything square and aligned. A square frame now will make the rest of the build much easier later. Once everything is aligned, secure the joints with hot glue and allow it to cool before moving on. Next, we'll install the LEDs. This is one of the most important steps in the entire build. Start with the female connector on the LED string. Locate the small arrow printed on each LED module. Notice how the white wire connects to that arrow. The arrow shows the direction that the signal travels through the LED string. Place the first LED in the lower right corner and begin working from right to left across the bottom row. When you reach the end of a row, snake back across the next row and continue until all 100 LEDs are installed. Once you reach the final LED in the upper right corner, cut off the male connector from the end of the string. Double check that you're cutting the male connector and not the female connector. Cut the wires about halfway down, then set that connector aside because we'll use it later. Now it's time to assemble the LED grid. Using the 18 pre-cut foam board strips, create a 10 by 10 grid. Slide the pieces together carefully until all intersections are fully seated. The finished grid should create 100 square openings that align with the LEDs underneath. With the grid assembled, place it over the LEDs and secure it with a few small dots of hot glue. Then carefully flip the assembly over and place it into the box so the LEDs and grid rest directly against the acrylic front panel. This should be a snug fit. Before securing everything, verify that the first LED, the one connected to the female connector, is still located in the bottom right corner of the box. Once everything looks good, add a little glue to hold the assembly in place. Next, we'll install the power switch and power jack. Snap the power switch into its opening and secure the power jack in the back of the box. Make sure everything is seated firmly so it won't move around later when power is connected. Insert each button into its opening and secure it from the inside. Attach one wire to each terminal on every button. You may need to apply a little pressure when sliding the wire connectors onto the button terminals. That's completely normal. Just make sure each connection is fully seated. Before we can connect everything to the Arduino, we need to prepare some jumper wires. Since we're using an expansion board, we'll be creating custom female jumper wire connections. Take your female to male jumper wires and cut them in half. Set the male ends aside because we won't need them right now. Strip a small amount of insulation from the cut end of each female jumper wire. These stripped ends will be soldered to the wires from our buttons, LEDs, and joystick in the upcoming steps. Now let's solder the female jumper wires onto the button wires. Before you begin, it's helpful to pre-tin the tip of your soldering iron with a small amount of solder. You can also add a little solder to the exposed ends of the wires before joining them together. This makes the final solder joint cleaner and easier to complete. Before soldering, slide a piece of heat shrink tubing onto one side of the wire. Once the solder joint is finished, slide the heat shrink tubing over the connection and shrink it into place. This protects the joint and helps prevent accidental short circuits. Remember that LED connector we saved earlier? We're going to use it now. Take the connector and solder female jumper wires onto each of the 3 wires. Match the wire colors carefully so everything remains consistent. Just like before, use heat shrink tubing to protect each soldered connection. When you're finished, you'll have a removable LED connector that plugs directly into the expansion board. Now let's install the Arduino Nano and connect the buttons. Press the Arduino Nano firmly into the expansion board, making sure the USB connector is facing the correct direction. Connect all of the black button wires to any black pin labeled G on the expansion board. All of the components in this project share a common ground, so any ground pin will work. Then connect the colored signal wires from the buttons to their assigned signal pins on the board.
The sudden sight, lost places where I started. The future, things that not fall before me spinning gone. No life is taking time, and in the sunken night, the world is born in candlelight. I'm in the surface shine. I don't need the perfect end in the self-the destiny. I don't need to save the world, I just need peace to know my mind. Oh, it stays off the world, no need to take control, just because I'm not the same. I know the me, now I'm too slow inside, lost pieces where I stay. The future, things that not fall before me spin it on. Is taking time, and in the something now, the world is born in gentle light. I'm in the surface shine. I don't need the perfect beat, and the self-the destiny. I don't need to save the world, I just need pasting on my mind. Oh, it stains all over, no need to take control.
Next, we'll prepare and connect the joystick. Create 5 longer jumper wires by joining matching wire colors together. Connect those wires to the joystick module according to the pin labels. If needed, you can remove the joystick cap temporarily to make the labels easier to read. Route the wires through the joystick opening in the side of the box and connect them to the appropriate pins on the expansion board. We're almost finished. Now connect the power switch and power jack wiring to the expansion board. Double check all connections before applying power. Make sure your ground and power connections are secure and that no bare wires are touching each other. Once everything is connected, upload the code to your Arduino Nano and power up the project. Test the buttons, test the joystick, and verify that all 100 LEDs are working correctly. If you'd like to build this project yourself, you'll find the Arduino code and a printable PDF guide linked in the video description below. And now comes the fun part. Customize the code, experiment with new animations, create games, build interactive displays, and make this project your own. With 100 individually addressable LEDs and a joystick controller, the possibilities are almost endless. Thanks for watching and happy building.